Lurking 400 million miles away is a planetary monster wrapped in colorful bands of deadly hydrogen gas, spinning so violently that it distorts space-time around it. This is Jupiter, the undisputed king of our solar system. For decades, its lethal radiation belts, capable of tearing human electronics apart in milliseconds, kept its deepest secrets hidden from view. But on July 4th, 2016, an armored explorer braved the onslaught. This is NASA's Juno spacecraft, a lone sentinel operating inside a specialized titanium vault, designed to peer beneath the impenetrable clouds of a gas giant. Unlike previous outer solar system missions that relied on nuclear power, Juno represents a triumph of modern engineering, operating as the most distant solar-powered spacecraft ever built. Its three massive solar arrays, stretching out like the blades of a cosmic windmill, harvest the faint, distant light of the sun. Its mission was deemed nearly impossible: fly closer to Jupiter than any spacecraft in history, dodge its crushing magnetic fields, and uncover the origins of our solar system. To survive, it had to endure a hostile environment akin to a cosmic particle accelerator. This is the complete, high-density chronicle of the Juno mission, an ongoing saga of a spacecraft that redefined planetary meteorology, mapped invisible gravitational anomalies, and changed everything we thought we knew about giant planets. This is the story of how humanity built a shield of titanium to pierce the heart of Jupiter, tracing our own celestial roots back to the very dawn of creation. Launched on August 5, 2011, aboard a powerful Atlas V rocket from Cape Canaveral, Juno embarked on a complex 5-year journey. Weighing over 7,900 pounds, the spacecraft required immense velocity to reach the outer solar system. Because rockets alone cannot bridge this distance, scientists executed a precise gravitational slingshot. Swinging Juno back past Earth in 2013 to steal orbital energy and catapult it toward its giant target. To protect its delicate scientific brain from Jupiter's lethal electron storm, engineers built a central radiation vault made of solid titanium walls, half an inch thick, shielding its flight computers from millions of rads of radiation. On July 4, 2016, Juno reached its destination. To avoid the deadliest zones of Jupiter's radiation belt, mission designers placed Juno into a highly elliptical polar orbit. This unique trajectory allowed the spacecraft to scream over the North Pole, dive low beneath the radiation belts within just 2,600 miles of the cloud tops, and exit quickly over the South Pole. Every 53 days, Juno executed these high-stakes close flybys, known as perijoves. Spinning twice every minute to keep its instruments stable, Juno began its unprecedented, deep-diving reconnaissance of the solar system's largest planet. As Juno lowered its instruments beneath the visible cloud tops, it shattered long-standing scientific assumptions. Using its microwave radiometer, Juno peered deep into the atmosphere, revealing that Jupiter's famous colorful bands are not superficial skin-deep features, but dynamic structures extending hundreds of miles into the interior. Surprisingly, Juno discovered a complex distribution of ammonia and a much higher abundance of water near the equator than previously estimated. This key finding provided scientists with critical clues about how the planet originally condensed from the primordial solar nebula. Juno's gravity science instruments mapped the planet's uneven mass distribution with staggering precision. Instead of a solid, compact rock at the center, the data pointed to a strange, diluted and fuzzy core. Scientists hypothesize that Jupiter's core may have been violently disrupted by a colossal impact with a proto-planet 10 times the mass of Earth early in its formation. Furthermore, Juno mapped an irregular, asymmetric magnetic field that is 10 times stronger than Earth's, revealing a bizarre, localized magnetic hotspot near the equator dubbed the Great Blue Spot, driven by deep currents of metallic liquid hydrogen. While Jupiter's equator features familiar horizontal bands, Juno's polar flybys revealed an entirely different world. At the North and South poles, the orderly stripes dissolve into a chaotic, churning abyss of monstrous storms. JunoCam, the high-resolution color camera, captured stable, geometric arrangements of polar cyclones that do not merge. At the North Pole, 8 giant storms form a perfect octagon around a central cyclone, while the South Pole features a pentagonal cluster of storms, each spanning thousands of miles across, large enough to easily engulf entire continents on Earth. The meteorology discovered by Juno grew even stranger. The probe detected high-altitude thunderclouds, producing an unexpected form of electrical discharge known as shallow lightning. Unlike earthly lightning that originates deep in water clouds, Jovian shallow lightning originates in high atmospheres, where an exotic mixture of ammonia gas acts as a natural antifreeze to liquefy water ice. This process creates falling stones of ammonia water slush, dubbed slush balls, which transport nitrogen and water deep into the planetary interior, rearranging the chemical composition of the atmosphere in a way never before observed on any gas giant. Having completed its primary mission, NASA approved an ambitious extended mission for Juno, transforming it from a Jupiter-only orbiter into a full system explorer. Juno redirected its trajectory to execute daring, low-altitude flybys of Jupiter's iconic Galilean moons. In 2021, Juno swept past Ganymede, the largest moon in the solar system, mapping its icy surface and recording the sounds of its unique magnetosphere. Soon after, in 2022, Juno zoomed past the frozen crust of Europa, capturing ultra-high-resolution imagery of its fractured ice shell and gathering critical data on the vast subsurface ocean hidden beneath. In late 2023 and early 2024, Juno targeted Io, the most volcanically active world in the solar system. Passing within just 930 miles of the hellish surface, Juno captured incredible views of active volcanic plumes shooting sulfur into space, glowing lava lakes, and towering mountains. It monitored how Io's intense volcanic output interacts with Jupiter's magnetosphere, feeding a giant torus of charged particles that drives the solar system's most powerful auroras. Juno's close encounters provided unprecedented insights into how tidal gravity forces keep a small world entirely molten. Like all epic voyages, Juno's mission must eventually reach its conclusion. As the intense radiation continues to degrade the solar cells and degrade the onboard instruments, the spacecraft will face its final operational phase. In accordance with strict international planetary protection guidelines, Juno will not be allowed to float through space as uncontrolled debris. If left adrift, it could eventually collide with habitable worlds like Europa or Ganymede, risking contamination from dormant Earth microbes. To protect the alien oceans it helped explore, Juno's journey must conclude inside the very monster it went to study. When the final command is executed, Juno will plunge intentionally into Jupiter's crushing atmospheric layers. Its thrusters will fire for the last time to stabilize the spacecraft, fighting a brave, brief battle against the violent Jovian winds. Just like Cassini at Saturn, Juno will transmit critical atmospheric data in real time until its solar panels are torn away by hypervelocity friction. Within moments, the titanium vault will melt, and Juno's atomic remnants will scatter across the cloud layers, becoming a permanent part of the gas giant. Juno's final transmission will mark the end of an era, leaving behind a monumental legacy of raw scientific data, thousands of breathtaking images, and an entirely new blueprint of gas giant architecture. The armored Voyager from Earth will be gone, but its insights will echo across the scientific community for generations to come. Thank you for watching. If you want to continue exploring the deep corners of our cosmos, hit subscribe and leave a comment below on which planetary explorer we should chronicle next.